Hello, what's up YouTube? Welcome back to another episode of I Make Free Energy for you guys on YouTube. Topic today would be electrosmog. EMF, electromagnetic field. So, question is now, what is that? Yes, it's a new form of pollution. Oh yes, guys. EMF and electrosmog, it's a new form of pollution. So question is now, totally legit question, where does this EMF and pollution come from? Well, yes, anytime we have an electrical circuit, any kind, for sure there is some kind of inductors inside of a bunch of components, including capacitors and everything, that does create like a magnetic field, that, yes, electromagnetic field. For instance, these are really common households, such as your air blower, your blender, and many other common households that they do create some kind of electromagnetic field. It's not as strong. No matter what country you are, there are some strictly regulations where how much really electromagnetic field you can release out of your devices. So yeah, no matter where you're from, there are some regulation about it. Of course, because as I said, it's a new form of pollution. So yeah, as I said before, every single device has some capacitance and some inductance. That's what creates the most of the electromagnetic field and electrosmog. So the most and fundamental electrical circuit that everyone can build, it's made out of a simple capacitor and inductance, or simply coil, in order to generate some EMF. But let's go take a closer look at what this circuit is about.
Let's go take a look of how we create some induction and wireless transmission. Of course, we need a transmitter and we need a receiver. In order to create some resonance, and the resonance is what creates most of the electromagnetic field we have around. The most elementary circuit you can build is called a resonance or resonator or simple LC tank circuit. It's very simple to make, and it's made out of a simple capacitance and an inductance. Our inductance, it's also commonly called antenna. Yes. So what's the theory behind it? Once you apply the charge to the capacitance, nevertheless to say the capacitance is going to discharge all the energy into the inductance. The inductance creates finally a magnetic field around it that creates also an equal and opposite charge to our capacitance that it will eventually recharge and discharge in an endless loop. Well, endless loop, it's a little bit too much, since we know that it doesn't really exist a perfect capacitance and a perfect inductance. So all the energy is going to get lost into a classic resonance waveform. So how do we avoid that? How do we avoid this energy loss? Well, we have to apply some little bit of power input and make sure it's a sine wave tuned to the frequency of this tank circuit. How do we calculate the frequency? Well, we calculate the frequency through this simple and elementary equation. The value of the capacitance and the value of the inductance profoundly relies on this equation. Should I say one more time? The value of the capacitance and the value of the inductance profoundly relies on this equation. Now, anytime the frequency changes, at this point it's kind of clever to understand that our capacitance and or our inductance, it's going to change, of course. Anytime you want to tune this simple circuit to such a frequency, you have to replace either the antenna, inductance, or the capacitance. There is no way that one single setup can listen to all the frequency. Of course, our receiver allow us to listen to this frequency, to catch the frequency, however you want to say it. And technically, your receiver circuit or tank resonance should be ideal and equal to the first one. It doesn't exist, as we said before, a perfect capacitance and neither a perfect inductance. So you try to work with the components you have and get as close as possible. So what kind of waveform we have as an output? Well, technically you should receive exactly the same waveform as you put as an input. Can we apply the load over here? Of course we can apply a load. Make sure your load, it doesn't require any DC current. Why is that? Simply because we're having a sine wave. In order to apply a load that requires a DC current, we need to add some extra component, such a diode. A diode ends up cutting the negative half wave. It's not going to be a perfectly straight wave because that will require an additional full rectifier bridge, other capacitance, and many other components. But for what we're going to do today, that's plenty of it. Should I say one more time that the value of the capacitance and the value of the inductance profoundly relies on this equation. So anytime you change the frequency, you will have to replace the capacitor and or our inductance. So now that we know the theory behind it, let's go ahead and build such a circuit. Alright, let's go take a look at this simple circuit. This very basic and elementary circuit, it's an excellent source of EMF, wireless transmission, and electrosmog, of course. Now, it's made out of a simple single transistor in a self-oscillating configuration that will generate our sine wave that it's going to feed our capacitor and inductance, a simple antenna. Everything is powered by 9 watts of overall energy from 4 AA, 6 volts, 1.5 amps. Our load is going to be a classic LED with a diode, a rectifier diode, and a capacitance. That's going to be our circuit receiver right there. Let's see how much power we can get out of this electrosmog. Right there, beautiful. Wirelessly, I can definitely get some energy. For as much as you want to improve the system, induction and wireless energy, it's definitely inefficient. Very, very, very inefficient system of gathering energy. Now, legit question will be how much power we can get out of this circuit. Well, the question is actually very, as I said, legit, and it requires a very simple explanation for it. If we know that each LED, it's about 6 milliwatts, or simple 3 volts, times 20 milliamps, technically we should be able to light at least 1,500 LEDs, 1,500 LEDs. Well, that's in theory. In practice, it's not really like that. We have a lot of loss in the system here. Where does this 9 watts goes to get lost? Well, into heat, of course. Our electrical components here, they generate heat, of course. And also we have to take in consideration, as we said before, it doesn't exist a perfect capacitance like it doesn't exist a perfect inductance. So the question remains the same. How many LEDs we are going to light with such an amount of energy? Well, let's go check it out then. Here I have another one. Let's put it next to it. Let's see what it does. Did you see that? We're going to light only one at a time, not all of them, because all the energy gets lost. The formulas and math never lies. Did you see that? You can pretty much light like a few of them. With this circuit, I can totally clever say that you can light more than 4 or 5 of these LEDs. Not even close to 1,500 of them. Not even close to it, because all the energy gets lost into the system. So one more time, induction and wireless transmission, it's definitely a very inefficient system to gather energy. Now, it's very useful to don't use cables and wires, but definitely to gather energy out of electrosmog, it's not that clever. However, let's go test our circuit and see what kind of waveform we got. Here I have a beautiful and portable oscilloscope. I didn't want to bring my big one, just too heavy and bulky, but this one will do just the job. Put it over here for a second. Attach negative to negative and signal to signal. That's a beautiful waveform, nice and clean. This is the waveform sine wave feeding our resonant circuit. We are talking about frequency of about 500 kilohertz. We can see that 500 kilohertz. Peak voltage, it's about 10.20 volts. That doesn't mean we're creating extra energy. It's just because there is a little bit of a joule teeth going on here. We're just raising the amplitude, but overall the energy will remain the same. Now, we should observe a very, very little detail that gives us a lot of answer. Did you see the voltage right there now? It is about 10.20 something. As soon as I apply a load to it, it will drop drastically. Of course it does. More than 2 volts. More than 2 volts anytime you apply a load to it. So can you really light 1500 LEDs? Well, I don't think so. As you can see, it works very well. But gathering energy out of wireless transmission, it's definitely a very inefficient system. So here is a common question that normally people ask. What if we try to improve not just the overall circuit, but also our antenna? How can we improve it? Well, as we said before, copper is one of the most conductive, though quite expensive material we have. Now, by mixing copper or with any form of magnetic material, such a metal of any kind, of just simply coating the antenna with another magnetic material, you just end up dropping the efficiency even more. And we can cleverly see that by putting a piece of aluminum foil in between the two antennas. Did you see that? We're pretty much absorbing all the electrosmog, or whatever you want to call it, EMF. Try one more time. There we go. Did you see that? So just by mixing or coating or putting something in between the two antennas, suddenly your efficiency drops. So you better off keep your antenna the way it is. Of course, if we're going to use a piece of paper instead of aluminum, the result will be quite different, because paper is not a magnetic material. Of course it's not. Did you see that? So you better off keeping the coil, your antenna, the way it is, without any coating, without any mixing with the strange alloys or any kind. So that's well proven right there. So now let's go take a look on our common households here. So we have our router here, we have our air blower, a lamp. For instance, we have my soldering iron here. Everything works here at about 50 to 60 hertz of frequency. Now, if we're going to do a little bit of math, in order to listen or to catch or to tune your receiver to 50 to 60 hertz of frequency, that will require an antenna just as long as 1,000 miles. Yes, 1,000 miles to listen to your household equipment right here. 50 to 60 hertz. According to our math here, we need an antenna just as long as approximately 1,000 miles. That's totally insane and totally useless to do. However, we have our router here that it works on 2.4 gigahertz. That's quite high frequency. The higher the frequency goes, the shorter our antenna is going to be. So let's go take a look on how much power we can get our our common house router. Let's go do it. So as we said before, if you wanna tune your circuit or catch some electrosmog around 50 to 60 hertz, you need an antenna that is just as long as 1,000 miles. Math and physics don't lie. That's the formula. However, today we are going to use rather our router. The router, it's a higher frequency, so it should be easier to listen to its frequency. Let's see how much strength, what's the signal strength out of our router. Let's see how much electrosmog we can get out of it. So here I download a simple software that allow us to see how much signal we can get out of our router. We are connected to my network right here, and that's the amplitude of the signal. So now it's not to the top. We're not having maximum strength, simply because we are actually standing a few inches away from the router. Yes, a few inches of air gap in between your computer and your router already drops the efficiency. Well, as I said before, wireless transmission, it's not really that efficient. On top of it, we have, no matter where you're from, your country, what it is, we have some strict regulations about it, on how much power you can get released out of your device. So now, here I have a piece of aluminum foil that we're going to put in between your computer and your router. As you can see, the signal drops even more. Just by applying a little bit of aluminum foil in between your computer and your router, you drop the efficiency. Let's do it one more time. Did you see that? It went down. See that? Pull it up, it goes up. Apply some aluminum foil and it goes down. There you go. And this is just by standing a few inches away from our router. So, what you call like electrosmog, it's not as dangerous as you think. And unfortunately, actually I would say fortunately, within a few inches away, already dropped its efficiency. So now, let's go ahead and take this computer and move around the house and see how much really electrosmog we can get out of our router. All right, we are standing a few inches away, and we clearly see that the energy, overall energy, wow, it's dropping drastically. We're actually standing not even a meter away from it. Did you see that? Well, let's keep moving. Let's keep moving. I'm actually now probably like 2 meters away from my desk. The efficiency is dropping drastically. So the signal and the amplitude is going to be pretty much useless in a matter of seconds now. All right, let's go in the other room and let's pass one wall. Let's keep walking backwards. Did you see how much drastically drops the signal? So we're standing about 5 meters away with a wall in between. Did you see that? You suddenly reduce the efficiency of 50%. Yeah, that's a good 50%. If I'm going to walk out the door, suddenly my electrosmog, it will turn useless. Yes, useless. No more EMF, no more electrosmog for our safety. Oh yes. So, this is another clever example that electrosmog, it's not as bad as you think. So, now we know how electrosmog works.
So now we finally understood what really electrosmog is. What someone on YouTube says, forget about your physics, forget about your formulas, I don't care, you're an engineer. All it takes, it's a very complicated machine to listen to all the frequency, yes, at the same time, and get a steady voltage to power all your devices. Yes, it's a very complicated machine. It's made out of like a spring, some very common magnets, and some tape. Yes, with this complicated device. You can catch all the frequency and forget about your physics. Let's take a look at this video. Tell me what you think.
Hi, first of all, it's a little windy, so sorry about that. This video is filmed on your requests. Many of you convinced me to film this. This is free energy resonator. This receives radiation of electromagnetic smog. Electrosmog is everywhere, even on unbuilt areas, so you can use it everywhere. Its output voltage varies depending on the electrosmog strength. This is a relatively known principle, but as you know, some powerful people don't want us to spread this idea. So I won't spread this idea, or better to say, I won't say how to make it. I only show you that this thing really works. By the way, this is a great idea because if you make more such resonators, you can power relatively big appliance. This is exact size, so if you want to do it smaller or bigger, it won't work. This is common node magnet with insulator. There has to be some insulator, otherwise it won't work. And this cylinder is to bring electricity from this coil. So let's test it. Please read whole description of this video and watch whole this video before you ask any question or before you comment it. I'm gonna make all measurements that you suggested in comments of free energy generator video, so as not to have to make any additional video. I'm outside, there is no transmitter near here, so you can see it works even in unbuilt areas. I also used LED diodes because, as you can see on other, by the way, fake videos, they are using only motors because they have small batteries in it. You must admit that I cannot hide here any battery.
So how was it? Did you see that? Spring in a magnet, it makes miracles. These guys makes really some kind of magic with that device. I should call it like a David Copperfield or something. Well, I'll tell you what, this guy is powering like a clever DC motor and a clever LED without using any extra components. It catches some AC or simply electrosmog sine wave and turn into like a DC without extra components. This device, it does everything at once. This device is just amazing, of course. I'll tell you what, I had a chance to replicate this device because I really want some free energy out of this guy. And yeah, I got my free energy. Take a look at my video. Tell me what you think. So did you like my free energy generator or simply resonator? In this next video, I'm going to show you that this simple device, which is a magnet and a spring, not only is going to power a source of DC load, such a motor and an LED, is actually going to power our 50 to 60 hertz power energy light, which is AC. Yes, before this device was creating some DC, now it creates some AC. That is amazing, all in one piece. This generator, it makes really miracles. So how was my resonator? I tell you what, these are simple energy saving lights. They don't work on 3 volts. It doesn't exist. A light bulb that works on 3 volts with this kind of thread. I can guarantee you that no matter what country you're from. So this one, no matter how many LEDs inside, it works between 120 to 220 volts. Yes, unless you really modify something in here. With this thread, there is no way it works on 3 volts. But this guy can light this thing with a simple device like that. Before it was 3 volts for an LED. Now it can suddenly generate 120 to 220 volts. This generator makes some serious miracles. I really want to believe it, but we are all open-minded, never skeptical. Take a look at my video, tell me what you think. So how was my free energy generator? Super cool, guys. I got free energy. I can tell you that. I'm gonna scale it up to, 50 to 1. I'm gonna make a big spring and a big magnet and gonna have free energy for the rest of my life, or at least for as long as the magnets last, which is quite a while. In this next video, actually, is trying to prove that there are really no Tesla coil or any form of EMF actually lighting the bulb. This guy here. There are no really source of any EMF. And you wonder, so where is the electrosmog comes from? It's supposed to catch the electrosmog, the antenna. Whatever, doesn't matter. Check this out. Tell me what you think about this video. This is super clever. So let's see if I can replicate this one too. Take a look, this is my free energy generator. So that's another video totally proven legit that we have free energy out of a simple resonator, a simple spring, and a magnet can do miracles. Okay, in this next video I'm going to show you that this guy really, people still don't believe in his video. So someone asked this guy, can you please take a look around and see if there is any source of RF, EMF, some kind of source of electrosmog. What this guy said, in order to really say, hey, there is really nothing around, it took the worst place on earth to make that freaking video. Yes, take a look at this video, tell me what you think. Did you see that? You went to a wide field, like a cornfield or something, where there is really nothing around, really nothing. Not even any form of electrosmog. Do you see any electrical devices nearby? Not even a power line. Within like a mile of a distance, at least as you can see. Seriously? So where is the electrosmog now suddenly? These videos are kind of clever. This guy is really proving his device is real. But the funny things are about this video and his channel, because he's collecting a lot of clicks and subscribers, are the comments. Yes, totally uneducated people, totally ignorant. They really believe in that shit. Yes, let's take a look at these comments. Those are the best. The first comment, it comes from this guy, Sanjay Pandey. I can't pronounce it, whatever he says. This is the real, because I know the theory before it and I was really a free energy generator. Like, totally, totally fall for it. Amazing. This guy is so clever. Okay, his English is actually worse than mine, but doesn't matter. What's next one? The next one is from this guy called Gary De Pietro. I think he wants to be pretending Italian last name. He says, this could have something to do with the Earth magnetic field. Would it be interesting to note any changes when oriented north, south, east and west? This guy's really trying to find any possible answer for it, when the trick is very freaking simple. This guy is totally like a kindergarten dropout, you can tell. He never finished even middle school, but he really wants to believe in that thing. He really believes in free energy because this guy made an antenna with a spring and a magnet, of course. Thank you guys for watching and please subscribe. I'll leave you guys my video with my video about free energy.